Hello friends, I'm here with one of the problem from finite element analysis. So today's problem is isoparametric quadrilateral element. So we have to find the local coordinates at point P. So the problem is this one. So this is an isoparametric quadrilateral element, and next, see, it has got four nodes, 1 2 3 4, and coordinates at node 1, node 2, node 3, and node 4 are here. These are the coordinates, and at point P, x is equal to 9 and y is equal to 6. So next, the value of x lies between -1 and 1. So next, what we got to do is this, the x value lies between -1 and 1. So we know that the equation that x is equal to x1 n1 plus x2 n2 plus x3 n3 plus x4 n4. This is the theoretical part. So for a quadrilateral element you must be having the knowledge about the theory, so, and the derivation. So let's substitute here x. The 9, x value is 9, so 9 is equal to, see here, x1 x2 x3 x4 values, substitute this, and here for similarly you have to carry out the y. Next, so shape function for quadrilateral element. This is the derivation part, and it is received from the derivation, so I don't derive this, and you have to refer the derivation or for the shape functions. So n1 equal to 1 by 4 into 1 minus xi into 1 minus eta, and for n2 1 by 4 into 1 plus xi into 1 minus eta. n3 is equal to 1 by 4 into 1 plus xi into 1 plus eta, and for n4 is equal to 1 by 4 into 1 minus xi into 1 plus eta. So next, so here n1 n2 n3 n4 we have substituted, okay, so in terms of xi and eta. So now at the end we have to receive the, or we have to calculate the value of xi and eta. For that, this is the substitution here. So n1 n2 n3 n4 here. So accordingly the n1 value we have to substitute here, that is 5 into n1. What is n1? n1 is this one, so we have to substitute here. Similarly for this symbols, according to the symbol we receive here, so this is plus 8 n2. What is n2? This one, we have to substitute here. Similarly for here, n 11 n3, 11 into n3 value, and next plus 5 into n4 value we have to substitute. And next 1 by 4 is common for this one. How? See, if you open this bracket and multiply, so you'll get 1 minus xi minus eta and xi into eta. So similarly here you have to multiply with this each other, and 1 by 4 is common, so initially I'll take 1 by 4 outside, that is 5 divided by 4, and here 8 divided by 4. This, if 4 comes out, 11 by 4, and if 4 comes out here, 5 by 4. So this term remains. We'll multiply each other and we'll get this values, okay. So anyhow 1 by 4 is taken out. When you multiply inside, so here 1 is common, here 1, here 1, so 1 into, take 1 out, 5 by 4 plus 8 by 4 plus 11 by 4 plus 5 by 4, this one, okay. Next, plus xi, everywhere xi is common here, okay. So for xi everywhere the value is 5 by 4 xi here. When you multiply with this side, 8 by 4 xi here, and here 11 by 4 xi, and here 5 by 4 xi. So what we'll get is xi is common, so now xi we will take it outside, and accordingly we'll write what is xi here, minus 5 by 4, plus here plus, it is plus 8 by 4 xi it was, so xi is common here, so it is 8 by 4 plus 11 by 4, because 11 by 4 xi it was, xi is common, so it is 11 by 4. Next, similarly here it was 5 by 4 xi and symbol is minus, so here minus 5 by 4 and xi is common. Okay, and similarly for eta and xi into eta. Okay, similarly you will get all common values. So next we'll solve this, because here 4 is common, so add it. 29 by 4 plus here 4 is the base and remaining numerators. Similarly here for denominator common numerator you have to add or subtract. Here you'll get all the values and at the end you'll get this one. Okay, similarly for y, for the y value here, this one y is equal to n1y1 plus n2y2 plus n3y3 plus n4y4. So similar substitution as substitution you have done here, same you have to substitute here, and similar method you have to use, which you have used it here, you have to use it here as well. And at the end after substitution you will get 8 is equal to minus xi plus 8 eta minus 4 xi eta. That is equation 2 I have made. So to get the to get the values of xi and eta, we'll make one changes, because we have to calculate xi and eta. So equation 1 is 7 is equal to 9 xi plus 3 eta plus 3 xi eta, and equation 2 is here, this one. So what I will do is, here it is 4 xi eta and here it is 3 xi eta. Therefore I'll multiply equation 1 by 4 so that I can make it 12, and this one I'll make it by multiply it by 3, and so that I can make it 12. So this 12 and this 12 it goes to 0. So add this, let us add this and this equation. So 52, 33, 36 and this is 0. So here in order to get xi or eta value, make this arrangement. You can use, calculate the xi first or eta first, it's up to you. So I have started with the xi. So xi is equal to 52 minus 36 eta divided by 33, and from equation 1, which here this equation, I'll substitute xi value. Okay, 7 is equal to 9 xi plus 3 eta plus 3 xi eta. So in the place of xi I'll substitute this xi value. So this is the xi value now here and here. So next step, solve this step and next step. So at the end you'll get this polynomial equation. Okay, so you have to solve this polynomial equation. Here two values of eta you will receive, one is this one and this one. So negative values we don't consider, so this is not required, so only positive value considering. So eta is equal to 1.1959. okay, substitute this in here, we'll get xi is equal to 0.2711. Thank you.